Use the quotient rule to derive the derivative of secant x. All right, well, what is secant x? Secant x is 1 over cosine x. So what I'm going to do is I'm going to label u, I'm going to label uv, and I'm going to remind myself that the quotient rule is the derivative of u over v is u prime v minus v prime u over v squared. So let's go off to the side and say, all right, well, using that information, u prime is going to be the derivative of 1, which is nothing. V prime is going to be the derivative of cosine, which is negative sine x. And then v squared is going to be 2 cosines, one multiplied to the other, so cos squared x. All right, so let's put it all together. The ddx of secant x is going to equal u prime v, so 0 times cosine x, that's going to make life easy, minus v prime, so minus negative sine, so a double negative right there off the bat, u, which is 1, all over cos squared x. Like that. All right, so things cancel out. Okay, u go away. Double negative is going to become positive sine x over cos squared x. So let's kind of split this up into something slightly more manageable. All right, I have one sine up here. I have 2 coses down there. So let's just, for this example's sake, split it up like this. Okay, this is perfectly fine. Because I'm trying to think like, all right, well, there's got to be a way that I can simplify this, and there is. So if I say sine over cos, I know that sine over cos is tangent. And I know that 1 over cos is secant. And so when all is said and done, I have my answer. The derivative of secant x is tangent x secant x. So, or some teachers might say secant x tangent x. It's the same exact thing. But when all is said and done, that's what I get. And we figured that out using the quotient rule. Fun, fun, fun.